Good morning, dear students. Let us continue with the new topic, that is what is suspension, and that is under the chapter number 2, is matter around us pure. So let's start the topic. Here we will see that here it is mentioned what is suspension. So what do you mean by suspension? Suspension is a kind of a solution or a mixture जहाँ पे हम देखेंगे कि solute particles जो है वो properly dissolve नहीं होते and they are suspended throughout the particular solution. So it is considered to be heterogeneous, that means homogeneous. So let's have few properties of suspension. Suspension is a heterogeneous. Why we will consider as heterogeneous? As we know very well, if we will have a glass of water, and that if we will pour few salt in it, then few spoon of salt in it, then you will see that it is suspended, or few parts will settle down and few parts will flow. So the suspension can be seen with the naked eyes. You can easily see that particular solution, and whenever you have a proper beam of light to be fall on that particular glass, you will see that the particles are scattering here and there. This last thing is, when you make that solution of soil and water for a few minutes undisturbed, you will find that the soil particles are settled down. They were at the bottom of the glass when they were left for a few minutes. So this is the whole scenario. After that, what you can do, you can easily separate the mixture by the process of filtration. So when the particles settle down, suspension breaks and it does not scatter light anymore. So this is the whole property for suspension. So for suspension, you must be aware that it will be heterogeneous. The very first property, you can see them with the naked eyes. It's a kind of a revision only, and through the beam of light you can see the scattered light there. Fine. So these three things must be kept in your mind while dealing with the suspension mixture. Now we will come to the next topic, that is what is a colloidal solution. So we had already studied in this book only the group D section, where we had done an activity. It is a kind of colloidal solution जहाँ पे हमने ink का expression एक example लिया था. So the particles of a colloid, they are uniformly separated through the solution. Let's have a look for that particular activity. This is the group D activity which we had done, as it is already mentioned regarding the activity number 2.2. So for D, what we had taken few drops of milk or ink, so that we will have a particular solution. So when we will take a few drops of oil or milk, what will happen? So they have the relativity in their size. That means कि हम देखेंगे कि साइज़ जो है वो एज़ कम्पेयर टू सस्पेंडेड पार्टिकल्स बहुत छोटी होती है. सो हमें ऐसा लगता है कि वो बिल्कुल यूनिफॉर्म सॉल्यूशन है. दैट मीन्स इट अपीयर्स टू बी होमोजीनियस, बट इट इज़ नॉट होमोजीनियस, and it is actually considered to be the colloidal solution. So at last we will conclude that colloidal solutions is a heterogeneous one, that is a heterogeneous mixture. For example, milk is the best example for colloidal solution. So the main feature or the main property for colloidal solution is that they are very small. That means which we cannot see from them from our naked eyes. So with the help of naked eyes, they can't be seen. And one more property which we had already done in suspension also, here we can see that these particles can easily scatter a beam of visible light. Here just see this activity. Here copper sulfate solution is given, and we have to follow the particular activity regarding a बीम ऑफ लाइट. सो यहाँ पे आप देखेंगे कि जैसे हमने यहाँ पे ये कॉपर सल्फेट सॉल्यूशन को डाला है, यहाँ से लाइट पास नहीं हो रही है, बट यहाँ पे हमारे पास वाटर एंड मिल्क है दूसरे बीकर में, एंड दिस सॉल्यूशन और दिस मिक्सचर विच कंटेन्स वाटर एंड मिल्क, इट विल शो अ पर्टिकुलर पाथ ऑफ लाइट विच इज़ विजिबल टू अस. That means it shows Tyndall effect. It's a very important topic. It will really help you in 10th also. So Tyndall effect is observed there, which shows that how a beam of light, and what do you mean by beam of light? Beam means what? A collection of rays. जब बहुत सारी रेज इकट्ठा होती है, इट्स अ पार्ट ऑफ कलेक्टिव नाउन ओनली, तब हम देखेंगे कि बीम ऑफ लाइट कंसिडर किया जाता है. जैसे आपने देखा होगा एक डार्क रूम है एंड आई हैव क्रिएटेड वन अ होल इनसाइड दैट पर्टिकुलर रूम, एंड व्हेन द सन रेज फॉल इन इट, यू विल सी अ पर्टिकुलर path of light visible in that particular room. So just like that, it's a Tyndall effect which will show scattering of light, and which will show that the particular particles or the smoke and air will be there in the particular atmosphere. So this is all about colloidal solution, and the best example for colloidal solution, as you can see, the canopy in the forest. आपने देखा होगा कि जब बहुत ज़्यादा dense forest होते हैं, you will see very डेंस फॉरेस्ट में आप देखेंगे कि बहुत टाइनी फॉर्म में वाटर ड्रॉपलेट्स भी दिखेगी, और लाइट का जो स्कैटरिंग है वो भी काफ़ी कम जगह पर देखने को मिलेगा. सो इट विल ऑल्सो अ पार्ट ऑफ कोलाइडल सॉल्यूशन ओनली, बट अगेन टिंडल इफेक्ट हम देखेंगे यहाँ पे कि टिंडल इफेक्ट का ऑब्जर्वेशन है जहाँ पे डस्ट पार्टिकल्स जो है वो डिस्पर्स्ड हो चुके हैं इन द प्रॉपर एनवायरनमेंट और इन द एयर. सो लेट अस कंक्लूड विद द पर्टिकुलर प्रॉपर्टीज़. When we go for colloidal solutions, the colloids must be heterogeneous. As we had already discussed, they may be heterogeneous, they must be heterogeneous. Particles जो होगा, they will be smaller than as compared to the suspension one. The next is, if we will consider colloidal solutions or colloids, we will see that they are big enough to scatter as compared to the previous solution. And just like that, if we will compare again with the suspension, where we had seen that हम लोग जब उसको अनडिस्टर्ब छोड़ देते हैं सस्पेंशन में सॉल्यूशन को, तो मिट्टी जो है वो सेटल डाउन हो जाती है. बट मिल्क के केस में ऐसा नहीं होगा, या किसी कोलाइडल सॉल्यूशन के केस में ऐसा नहीं होगा. सो colloids is just already a stable one, and वो सेटल डाउन होने पे या फिर हम कंसिडर कर सकते हैं कि हम उनको अनडिस्टर्ब छोड़ भी दें तो भी वो सेटल डाउन नहीं होंगे. सो दिस इज़ द मेन प्रॉपर्टी, सो मस्ट रिमेंबर दिस. The last property is that they cannot be separated from the mixture by the process of filtration, as we had already seen in suspension, where we can separate them with the help of filtration process. Here what we need a very special technique of separation, that is centrifugation. Yes my dear students, centrifugation, you must have to go through that particular process. What is centrifugation? We will further study in our activity also, activity number 2.5, when we will come to that particular activity of centrifugation, where we will separate cream from milk. Then we will study it more descriptively. So let's complete the particular solution part. So what we will see that they are not be separated by a simple filtration process. They need an ultrafiltration process, that is termed to be the centrifugation. So जितने भी पार्टिकल्स होंगे कोलाइडल सॉल्यूशन में, वो अब सॉल्यूट सॉल्वेंट के फॉर्म में नहीं कंसिडर करे जाएंगे, वो अब डिस्पर्स्ड फेज और डिस्पर्जन मीडियम के फॉर्म में होंगे. दैट मीन्स वेयर वी विल हैव सॉल्यूट, अब उस सॉल्यूट को हम लोग कंसिडर करेंगे एज अ डिस्पर्स्ड फेज. एंड सॉल्वेंट को हम लोग कंसिडर करेंगे एज अ डिस्पर्जन मीडियम. सो जस्ट रिमेंबर दीज थिंग्स. सो व्हाट वी विल सी, if we will take an example for that, like the solute, if we are taking any solute like component or dispersed particle in a colloidal form, you will see that dispersing medium will be more effective. And if the main thing which we will study here is that the more elaborate form, here you will see in all the form of states like solid, liquid and gaseous. So it's a very interesting table. Here you can see easily some examples of colloids, where you will see that dispersed phase is liquid and dispersing medium यानी गैस में लिक्विड होता है. then what we will see, it's a kind of aerosol like fog, clouds and mist. आपने देखा होगा कि एटमॉस्फेयर में किस तरह से क्लाउड्स फॉर्म होते हैं. इट्स जस्ट बोल सकते हैं कि हम वाटर ड्रॉपलेट्स एक कंडेंस फॉर्म में मिलते हैं एंड इट विल फॉर्म अ प्रॉपर क्लाउड. सो इट इज़ द बेस्ट एग्जाम्पल फॉर एरोजोल. द नेक्स्ट वन इज़ सॉलिड डिस्पर्स्ड इन गैस. So when solid dispersed in gas, we will see again aerosol. A good example for this is smoke. The next example is when gas is dispersed in liquid, it will form foam. Foam, that means shaving cream में आपने observe किया होगा, वो उस form में बनेगा. And liquid in liquid देखेंगे तो immersion, that is the best example for immersion is milk only. In the same manner, similarly we will have all the other types of arrangement. So you must remember when we will have aerosol, when we will have foam, when we will have emulsion, and when we will get gel or any other solid solution. So just observe the whole table and consider it again and again so that you can remember all these things, and try to learn at least 2 examples for each and every type. Thank you so much.